So now we are going to learn left rotate an array by k place. So we're going to learn left rotate an array by k places. K places. Here the k given is k equals to 3. Okay. So what the question is saying is we should need to left rotate these first three elements, right? We need to left rotate the array, but we should need to left rotate. We should need to put these three elements at the last. So once we left rotate this array, then how it will be look? It will look like 4, 5, 6, 7, 1, 2, 3. This is how it looks, right? This is how it looks. So as from the previous problem, so what I'm going to do is I'm going to create a temporary variable. I say temporary is equal to 1, 2, 3. The first three elements will be in the temporary, right? Okay. So now what I'm going to do, so I'll start shifting. What I'm going to do, I'll start shifting. So what I'll do here is I'll take a for loop for I equals to k. I say I equals to k. Why k? Because we start the iteration. So okay, let me first write the index 0, 1, 2, 3, 4, 5, and 6, right? So we have given here k equals to 3. So we should need to start the iteration from here, right? From here. So I is less than n, then I'll increment. Then I say array of I minus k is equals to array of I. So what will happen here is this 4 will come to the first index. This 5 will come to the fifth index. This 4 will come to the 0th index. 5 will come to the first index. And 6 will come to the second index. 7 will come to the seventh index. Third index. Okay. It was done. Shifting was completed. Right? Okay. So okay, what I'm gonna do now, I'm going to put back to the temp. What I'm gonna do, put back to the temp. Put back to temp. But how can I do this? How can I do this? So here it has 0th index, first index, this is second index. What I'm gonna do is I'm going to put this 1 here, right? This will be n minus t. Why n minus t? What is the n size of the array? So the size of the array is 7. And sorry, here k, n minus k, and k is equals to 3. Then 7 minus 3 is equals to fourth index, right? We need to put this element in the fourth index here. You can see here, this is the fourth index, right? Okay. Now this 1, this 2 will be here. This is n minus k plus 1. Now this will be here, right? This will be n minus k plus 2, right? So okay, let us try to quickly code this thing. So what I'm going to say is I'm going to write a loop I equals to n minus k, right? N minus k because we're going to start the n minus k because we're going to start inserting start putting back the temp from the fourth index, right? Okay. Then I is less than n, I'll increment. Okay. Here what I'm gonna say is array of I is equals to temp of I minus n minus k. Why I minus n minus k? Let's do it. If I say n minus k minus n minus k plus 2. Then what will, then what index I get? Then I get the second index, right? Second index. So this is why we say, so if we do this, we'll get 0th index, we'll get first index, we get second index, right? Okay. Okay, let's try to do this step 1 first. Step 1. This, what is step 1? Why are you going to do this? So I say, so in step 1, we're going to insert, we're going to add the elements. We're going to add the elements here, right? For that, we're writing step 1. So what I say here is I equals 0, because we're going to start from 0th index, right? 0th index here is 0th index, right? Okay. I say I is less than k. Then I will increment. I say temp dot list dot add array of I, right? Okay, good. So let's try to analyze the time complexity for this. So this is a brute force solution, right? So this is a brute force solution. So let's try to analyze the time complexity for this. Okay, let's start from shifting. So in this shifting, what is the time complexity? This is big O of k, right? Okay. So this is big O of k, and what will be the time complexity when we push back to the temp? Then it will be big O of n minus k, right? Then what will be the time complexity when we do the step 1, when we add the temp list to the array? Then it will be big O of k. So okay, let's say time complexity will be big O of k plus big O of n minus k plus big O of k. So this is for step 1. So this complexity for step 1, this is for shifting. So this is for pushback. This is for pushback to temp. Okay, what will be the space complexity? Space complexity will be big O of k. Why big O of k? Because we are using an extra space, and that extra space is, we have created another temp array, right? Because we are using extra space, the space complexity will be big O of k, and the time complexity will be big O of k plus big O of n minus k plus big O of k. So Jay, before we are moving to the optimal solution, let me explain this. I forget to say this. So the time complexity will become big O of n plus k. Okay. So the time complexity for brute force solution is big O of n plus k. Okay. So let's try to look the optimal solution. Here the given size of the array. Here the given size of the array. Okay, sorry. Here the given size of the array is equals to n equal to 7, then k equals to 3, right? Okay. First, how to do the optimal solution? How to do the optimal solution? First, I'll say we should, let's try to see what is the answer of optimal solution. How it look like when we left rotate it? Then it will be look like 4, 5, 6, 7, 1, 2, 3, right? So okay. First, why we are going to do? What we are going to do is, so okay, we're going to reverse these three elements, these three for elements. Then it will be look like 3, 2, 1. So next we're going to reverse these four elements. Then it will be look like 7, 6, 5, 4. Okay. Then again we reverse this, then we get this, right? Then the array will be left rotated. Then if we rotate this, if we reverse this, then the first we get 4, then we get 5, then we get 6, then we get 7, then we get 1, then we get 2, then we get 3. So this is how left rotated, the array is left rotated using the optimal solution. So okay, but how to reverse this? Let's try to see. I say reverse a to a plus k. I say reverse a to a plus k to a plus n. Reverse a to a plus n to a. So here the time complexity will be big O of k. Here the time complexity will be big O of n minus k. Here the time complexity will be big O of k, right? So this, why do we rotate this? We are reversing. So here we are reversing 0 of k elements. Here we are reversing 0 of n minus k elements. Here we are reversing the whole array. Here we are reversing the whole array, right? So okay, here is n, right? So we should say n. So this is n, not k. Okay, this is n. Okay, big O of n for reversing the whole array. So what is the time complexity? So I'm gonna cancel this a plus a minus a cancel. Then the time complexity will be big O of 2n, right? N plus n plus n is 2n. And space complexity will be big O of 1, right? Because we are not using any extra space. We are just modifying the given array, right? We just left rotate the given array, right? So this is the optimal solution to left rotate an array using k places. Okay.